So now we are introducing the quicksort algorithm. So what is quicksort algorithm? This is a place sorting algorithm that we pick a pivot element from an array and use the partition into two sub-arrays. So every element with less than the pivot are moved to the left sub-array and greater than the pivot will move to the right sub-array. And this algorithm will sort recursively. On average, the quicksort will run all n log n time, and in worst case, it will run all n squared time. So how does it work? First, we have to pick a pivot from the array. So in this case, we will use this median, for example. So step 2, we will rearrange the array. First, we will move the element less than pivot to the left side, and the value greater than pivot, we will move it to the right side. And divide the array into two smaller sub-arrays. So when the left and when the partition is done, the pivot is sorted. So we will recursively sort the left sub-array and right sub-array until it left a single element. This is our base case. So this is our pseudocode. So the base case is like we reach our base case. We only left for one element. And how do we pick the pivot? It's the median. Median equals to start index plus end index divided 2. So this is our pivot. And left index is start index. And the right index is our end index. So the while loop is like we will find the element which is less than the pivot, we would stop. And bigger than the pivot, we will stop. And this is smaller than pivot, we will stop. And then when we find the element, we will swap it. And then we will move the left and right pointer. And when the right pointer is less than left pointer, the partition would start at here. We will continually recursive the left sub-array, and when the left sub-array is finished, we will continuing for quicksort for our right sub-array. And now let's implement in VS Code. So this part is about the quicksort code. So first, we have to use our main function. Let's find order. And so, and input is non-array. And okay, so our result would be call our quicksort function, and then input is none, and okay, so finally we would return our result, but in case our result is not null, we would like to check this edge case. Then this is our main part for the quick sort. So input is nums and the start and end index. And then the base case is it means that there's only left for one element. So how do we pick the pivot? Is the mid right? So the pivot equals to split and left and right equals to, and then start our while loop. Well, left, well, left or equal than right. And then we have to find the nums left is bigger than the pivot. Then if we don't find it, we will keep move our left pointer. And at this point, we would like to find a smaller one. And if the right pointer points the element is bigger, we will keep move our right pointer. So less than nums right. So we will keep moving our right pointer. So if we go out of bounds, so we will swap it. So and then after we swap that, we would move our left and right pointer. And then when we're done, we have to call our left and sub array. And we will continually call the quick sort left sub array and right sub array until every part is left for one element. So this part is for the start and right. This is the left side. And the other side is nums left and end index. So, oops, it has two. So when we done this, we finish our quick sort function, and then we will check whether our answer is right or wrong. So the answer is right. So now it is graphical explanation. So first we have to find the pivot. So the pivot is at the mid index. How can we get the mid index? Is start index plus end index and divide to 2. And left and right index is start index and end index. So now we have to find the mid. So the mid is 3. So our pivot is right, and our left index is 0. And our right index is 6. So in this code, we have to find when if the pivot is bigger than the array, a left pointer's element, we have to keep going until we meet this element is bigger than pivot, right? So 8 is bigger than 4, so we stop here, and at this point we have to find smaller than the pivot. So we have to, like, 9 is bigger than 4, 11 is bigger than 4, and 4 is bigger or equal than 4, right? So the right pointer is here. And when it comes to here, then we check, is left less or equal than right? Yes. So we swap it. After swapping it, you have to move the left pointer to here and right pointer to here. So let me write the current array. So it's like 4, 5, 2, 8, 11, 9, 2, 2. And your left pointer is here and right pointer is here. So at this time, we also want to find the pivot is 4. Left pointer, we want to find bigger than pivot, right? So 5 is large or equal than 4, and 2 is less or equal than 4. So at this time, we just swap again. So this is 2 or 5. And now we have to change the left and right pointer. So the left and the right. So at this time, our left pointer is bigger than the right, right? So we have to call so this partition is finished. So at this time, we have to call our quick sort. So this part is left subarray, and this part is our right subarray. So we have to go to find our left array. So we call quick sort nums and the start index and our right pointer. So our right pointer is 1. So 4 and 2, right? So the left pointer is here, right pointer is here, and our start and end index. So 0 plus 1, this is pivot. So 4 is bigger than large or equal than 4, and 2 is and then they need to swap it again. and then the right and left pointer is here. So now we have to continue call our left subarray because we haven't reached our base case. So our left subarray is here and our right subarray is here. So we call start index and right index. So because the start index is large and equal than n index, so it reached our base case. We just return. So it means that the two element is sorted. And same, we have to call our right pointer. A left pointer is left to end and index. So this is so because the start index is larger or equal than the end index, so we stop searching. So 4 is also sorted. So it means that in this part we are finished. So in this part we will divide it again. So 5, 8, 11, 9, 5, 8, 11, 9, 22. So this is 3, 4, 5. So this is index. And now we have to find our pivot. So our pivot is 11, right? So this is our left pointer, this is our right pointer, and then our pivot. So at this time we have to find a bigger one. So the left pointer is here. And the right pointer is here because not is less than 11. So now we have to swap. And then our left and right pointer have to move. And at this time, our right pointer is less than left, right? So it means that our partition is stop. So we have to continuing call our left subarray. It means that it is our left subarray, and this is our right subarray. So at this time we have to call 5, 8, 11. So this is left subarray. And then the median is 2 plus 4 divided to 2, so the pivot is 8, right? And this is our left and right pointer. So we have to find. So we have to find the bigger one. So, and the right pointer would also be index 3. So 8 is exchanged to itself. And the left pointer will move to here. And the right pointer would move to here. So because the left pointer is bigger than bigger than right, so we continuing call our left subarray. It means because the 8 is pivot, so this position is sorted. So our left subarray is only 5, and our right subarray is 11. And then we found that we call the left subarray is equal to nums to 2. And we found that the start index is bigger or equal than end index. So it is reached our base case. So return, and the 5 is sorted. And saying the 11 is the right subarray. So we call the quicksort for 4, and 4 is large or equal than 4. So the 11 is sorted. And then what do we left? So the right subarray 11 and 2, right? Yeah, 11 and 2, 11 and 2, and this is 5 and 6. So the left pointer and right pointer and our pivot is here. So our left pointer, right pointer, our right pointer will move to here, and 11 change to itself. So the 11 is sorted because 11 is pivot. So we only left for 22, right? So the 22 will call the right subarray. So we reached our base case because the start index large or equal than an index. So the 22 is sorted again. So until this case, we already sorted every element in this array. So we can get 5, 2, 5, 2, 4, 5, 8, 9, 11, 12, 22. So this is our graph explanation.